haven't looked ahead, Chapter 9, not very long. Okay? I don't think. I think Chapter 9 is just not a super long set. I don't know whether it's a plus or a minus. The 4 star days, we're not going to do much in the way of new material. Okay, we may do a little bit tomorrow, 4th period, but most of tomorrow we'll just deal with answering questions and then maybe giving you a little more practice, but not going on to new material. All right? So, with that said, we're looking at solving right triangles. And we remember back to the unit circle, radius of 1, theta being the angle from horizontal right. We know that the coordinates of the point on the unit circle are cos theta, comma, sine theta. And we know all the identities, cos squared plus sine squared equals 1. We've done a lot of that kind of stuff. What is the tangent of theta equal to? Sine theta over cos theta. Where does that come from in terms of the triangle? Opposite over adjacent. So opposite, this is the opposite side. This is the adjacent side. And this is the hypotenuse right here. Okay? So nothing new, nothing different, just another, don't forget, tan theta is sine over cos. Tan theta equals sine over cos. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So for this triangle ABC, where C is your right angle and theta is where A is, the sine of theta for this is opposite BC over hypotenuse AB. And same with cosine, it's AC over AB, adjacent over hypotenuse. And again, in general, tangent is opposite over adjacent. How's that triangle so big? Everybody good on the big 3? I know it's a review, we're not trying to beat it to death. Sine, cos, tangent. You might remember SOHCAHTOA. Okay, SOHCAHTOA, that's all related to the big 3. Sine, cosine, tangent. If you're not familiar with SOHCAHTOA as a word, just put these 3 things together. It's the mnemonic to remember the trig ratios. It comes from the first letter. Here, sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, T-O-A-C-A-H. Okay, big 3. Sine, cosine, hypotenuse. Now, the little 3, Shoshakao, like we're going to another country here. I don't know that you're going to remember that word, but really, cosecant, hypotenuse over opposite. Secant, hypotenuse over adjacent, and cotangent, adjacent over opposite. So I don't know if we're going to make a new word out of it. Probably not. They are the reciprocal identities from the big 3. So opposite over hypotenuse becomes hypotenuse over opposite. If you know the little 3, you probably know the big 3. Everybody good here? Is there a mistake, Nate? No. Sure? Yeah. You good? Yeah, I don't want to go on if you're confused. 3 decimal places is really what I'm looking for, more than 3 significant digits. Okay, so example 1, we're looking for the value of B in this triangle with this given information. This is what I would call a sterile problem. It's not an application. It's just, here's a triangle. It has no meaning for us whatsoever. this angle A is 28 degrees. Little a, little b, little c. Does everyone know why it's little a, little b, and little c? Is anyone not clear on that? Because when you draw your own pictures, you need to label them correctly. My assumption is you all get ABC, little a, little b, little c. Anyone not clear on it? Correct. So if this is capital A, angle A, the side opposite is little a. And you can choose whatever letters you want, but the sides are lowercase, the angles are capitals. Okay? So what equation will allow you to solve for B in this particular problem? And you're limited to 4.
Cosine, it's like opposite over adjacent.
So what do you want me to write?
So having 28 degrees equals 40 over.
You want me to write 28 degrees equals 40 over B?
I just know that the cosine would be 28, and the opposite would be 40, right?
So if we solve this, you're going to get 28B equals 40, and B is going to equal 40 over 28. You got a calculator? What's 40 over 28? 1.42. 428. Okay. Take a look at our triangle here. Who can tell me which side is the longest side in the triangle? C. And which side is the smallest side in the triangle? And which side is in between? Got to be B. Little angle, little side. Smallest side I got is 40. That's smaller, right? So that's bad. So Nate, I let it go all the way through, really just so that we could see what would happen there. There we go. So I wanted you to see what would happen. You said one thing, but you told me to write another. Okay? Now, what you said was incorrect also, but it would have been better than what I wrote. Do you know what you said first? And what was that equal to? Of? Yes, you did. The cosine, you can't just have the word cosine. Of? No. Let's go back and look at our equations. What does this stand for when we talk about the cosine? Theta. Theta, yes, I know it's the theta, but what is theta? It's a variable. What does theta represent for us? Not helping. Okay, let's go back here. What does theta represent? An angle measurement. You can't take the cosine of a side. You can only take the cosine of an angle. And the cosine of an angle is equivalent to the length of the side adjacent to the angle compared to the length of the side opposite the angle.
Okay, so just.
Okay, so let's go back here. When you said cosine, it should have been cosine of. Is equal to. Correct. So it would be. Correct. 2 unknowns, right?
Yeah.
Not helping. But right now you're on the right track.
So we could find C. Opposite.
Don't want to know what C is, but we could. I mean, that would be one of those things for make work. If you like to do this stuff, we could do some extra problems.
Yeah, that'd be fun.
So what can we do here? Marissa? Only if you're really, really smart would you do that. So what would the measurement of B equal? Yeah, but these two angles are going to be complementary always. So you just do 90 minus 28, and B is going to be 62 degrees. And why would you want to do that, Marissa? The sine of 62 is equal to,
B over, never mind.
how come? How come never mind? Because we don't know the hypotenuse yet. Of tangent of 28 degrees is equal to 40 over b. In order to solve for b, you're going to multiply by b. B tan 28 equals 40, and the equals 40, and b equals 40 divided by the tangent 28. That's not very much fun. If you were on Marissa's team, instead of tangent of 28, let's go tangent of 62 equals b over 40. So 40 times the tangent of 62 is equal to b. Having your unknown in the denominator is not a good thing. Your two acute angles in a right triangle always add up to 90. If you know one, you know the other. Both equations will give you the correct answer. And it means you have to be in degrees on your calculator. 40 tan 62, or 40 divided by the tangent of 28, what does b end up equaling? 75.229, which is good because it's more than 40. 75.229. You also could do the top one. It doesn't really matter. You're going to get the same answer. Why can't you use sine or cosine to find b? You don't know c, the hypotenuse. You have to use opposite and adjacent. So what you're looking at is, what do I know? I know the angle. I need the adjacent. I know the opposite. That's TOA. OA. TOA. Tangent. If you use this angle, it's TOA. Opposite and adjacent. Okay? Take a look at example 2. See if you can find little c, big B, and big C. First thing we want to do, draw your picture. What angle's here? A. So this is A, right angle. What's angles here? Doesn't really matter. B here, C here, that's fine. If this is B, how long is this side? 21. And this side is 29. And this side is, okay, little c. And we're supposed to find the two missing angles and the missing side. All right, how do you find the missing side? Pythagorean theorem. Now, some of you are known for writing these micro pictures. Micro pictures save trees. I agree. I'm a big believer in kill the trees, write bigger. Okay? If you're really concerned about the ecology, recycle. I'm all for that. I do it all the time. So, bigger pictures will help you. How do we find c? C squared plus 21 squared equals 29 squared. C squared plus, what is it, 441? 720, no, 9, 8 what? 841. So when you subtract, you're going to get c squared equals 400, so c is, nice. So if you knew your Pythagorean triples, 20, 21, 29, so.
We find the angles for again.
Doesn't matter. But you shouldn't be using an angle to find the side when you can use the three sides in Pythagoras, because if you use a rounded angle, then you're gonna get the wrong answer. Or it's gonna be off slightly. Okay? So how many more angles do I need to find with an equation? One. Which one do you want to find? B? Which trig equation? Sine of angle B is equal to 21 over 29. So angle B is equal to sine inverse of 21 over 29. What does angle B turn out to equal? 46.397 degrees. $90 minus that answer is going to give you 43.603. And then little c, we found that too, is equal to 20. Now you could have used any trig function you wanted with b or c, sine, cosine, or tangent, because you know all three sides. You could have found angle values before you found the third side. Doesn't matter. Okay? Questions on this one? Is there anything you want to say about angle B before we move on? And how you found angle B and something to think about for the future? How did you get angle B up here? No, you did not. How did you ultimately determine the value of angle B? Yeah, but by doing what? You did not. You did the inverse. What have you learned in the last few chapters about that? Two possible answers. Okay? And I know that it doesn't matter right now, because what do you know about the other angle whose sine was 21 over 29? Where is it? Quadrant 2, so it's definitely going to be too big. It's going to be more than 90 degrees. So that there's no way this could be an obtuse angle and still be a right triangle. But that's not going to be true later on. All right, when we do law of sines and law of cosines, that's not going to be true. So just keep that in mind whenever you're doing sine inverse. Just put a little note in your brain that there's always two answers. In right triangle trig, that doesn't matter to us. But later on, it will. Okay? So you go to the store, you buy a ladder, and of course, you know, you men out there for sure are going to read the directions on how to use your ladder. You know, on every ladder, you're usually stuck right on the side. We're talking about those ones that, you know, you push them up and they get 20 feet tall. It tells you stuck right on the side that the angle with the ladder in the ground should not be more than a 70-degree angle for safety purposes. If you've ever climbed up a ladder and the angle is more than 70 degrees, you know when you get at the top, there's that feeling like it wouldn't take a lot to pull and have the ladder go up over. And then you get slammed into the ground. Okay? So they put this on there to protect themselves liability-wise. They can't protect you from your own stupidness. All right? So you look at this and you say, well, here's the ladder right here. This angle has to be 70 degrees or less. Because if you try, I got to get up to here. Oh, I got to get up to here. You know what I could do? Just this one time, we'll slide the ladder in and use an 80-degree angle, and I'll be able to reach that. I'll visit you at the hospital. Okay? So, 70-degree angle, the ladder's leaning against the house, just like I showed you. Find out how far from the base of the house, because you're not going to get out there with a protractor. Just figure out what the bottom distance has to be, and then how high up the house can you reach. Now, we got a 20-foot ladder. That means this is 20 feet. Most houses, what will this angle be? Most houses are going to be 90. We want to know what X and Y are. We want to know how far away from the house can I put the ladder, and then how high up the house will it reach? See if you can find those two things. Rach, give me one of the equations used to find either X or Y, whichever you want.
I did sine 70
Sine of 70
equals X over
equals X over 20. Sorry about that. So then 20 sine 70 is equal to X. What did X turn out to be?
18.7.
In what measurement? Feet. Okay, because the ladder's in feet, our height up in feet, okay? Yeah, bring it.
Sine 20 equals y over 20.
Sine 20 is equal to y over 20. Using the length of the ladder as this 20. And this 20, where'd that come from?
I found it by subtracting 70.
This is 70 down here. 90 minus 70 is going to give you a 20-degree angle here. See you tomorrow.
See ya.
Yes.
So 20 sine 20 is equal to what? What's 20 sine 20?
6.840.
In unit of measure? Why? Yeah. You have no idea why we're measuring in feet? How long is the ladder? 20 feet. Why are we using feet? Because it says somewhere in here that the ladder is 20 feet. What's that? That's how you should find X and Y for this. What I don't want you to do is to use Pythagorean theorem once you found X, do Pythagorean theorem to find Y. Because that means you're going to use a rounded value for X to figure out what Y is, and you may be off by 1,000th place. And that's not going to be very helpful. So you shouldn't be more than 6.8 feet from the house. Or you shouldn't be closer, I should say, than 6.8 feet from the house. Or you're risking that when you get up to the top, you could lean and pull the ladder off. There's nothing you can do once that happens. That's the chute didn't open. Enjoy the ride. Okay? Everybody good on this one? Try this one. What's the equation you're going to use?
Inverse tangent of
That's not the equation I want you to use. That's the second line of the equation I want you to use. Tangent of A equals 553 over 100. I don't want you skipping your initial trig equation. Then it's A equals tan inverse of 553 over 100. Or 5.5 for whichever you want to use. And what did you get? 7, 5, and that's degrees. Questions on that? All right. So everything in the book in your homework tonight, get me 3 decimal places. Not to be confused with his brother, Wiz. 830-meter tall building. 100 meters from the base, buried to your eyeballs. Again, what's the angle? All right, what's the equation? What's the equation? No. What's the equation? Tangent of theta. Tan theta is equal to 830 over 100. So now you can do tan inverse. And theta ends up being what angle? 8, 3. Okay. Good. Your uncle's building this, huh?
I'll ask him what he does.
Okay. This one you need to think about, okay? And this is all about the picture. You get the picture wrong, everything you do after you're toast. Let me give you a hint. And fumble. Let me give you a hint. This section is called solving right triangles. Okay? This section is called solving right triangles. So in this problem, I'm telling you, you have a triangle sides length 8, 8, and 4. Find the measures of the three angles of the triangle to the nearest tenth of a degree. I would prefer 3 decimal places. Okay, so your picture, lengths of sides, we're going to go 8, 8, and the bottom side is how much? 4 down here. First thing you do in your picture, split it. We know isosceles triangles, we know that they're going to split nicely into 2 right triangles. So we're going to get a right angle here and here, which means this is 2 and this is 2. What are they asking you to find? All the angles. How many angles do you need to find using trig? 1. Remember, t-shirts for you guys. Lazy. So we want to do the least amount of work. Let's call this angle here theta. How do I find theta? How can I find theta? You could do the cosine of theta is equal to, bless you, 2 over 8. So theta is equal to cos inverse of, if you want the decimal, you could do 0.25. Or you can just leave it 2 over 8. Bless you. Wow. Anna's probably thinking, wow, no shower needed today. Right? What was theta? Right. 0.478. I don't think so.
No, it's not. It's 75.
I got some harmony work in there. How much? 522. Right? Let's look up here. What's alpha? And the angle that we're missing in the triangle here, which is 2 alpha, so if we call this A, B, C, A is angle A is equal to angle B is equal to the 75.522 degrees. Wow. Angle C is 2 alpha, which is So 28.956. Someone needs to check me.
Yeah.
Okay. Questions on the three angles of that triangle? And how we go about getting them, and what we have, and what we can do. Other ways to do it, but they're all going to take longer. So the sine of 55 is x over 10. So 10 times the sine of 55 is equal to x. What'd you get? 10 sine of 55. 8.192. Don't use the rounded value to double now. Double it, hit times 2 right away. So AC is going to equal 16.383 centimeters. Now, some of you might be tempted to do Pythagorean theorem now. I would suggest you go back and do another trig problem. Again, you have multiple options. What trig equation should we use for the second diagonal? Sine of 35 equals y over 10, and 10 times the sine of 35 is equal to y. Times the sine of 35 is equal to y. What's y equal? And if you double right away, 11.472. That's not y at all. ED 11.472 centimeters. Any questions on either diagonal?